This is an area that is used to earthquakes.
A huge earthquake, and much stronger than the quake in Haiti.
We move on now to Chile tonight and to a massive earthquake.
Chile, the powerful 8.2 earthquake.
The 2010 Chile earthquake occurred off the coast of central Chile on Saturday the 27th of February at 3:34 local time, having a magnitude of 8.8 on the moment magnitude scale, with intense shaking lasting for about 3 minutes. According to official sources, around 500 people died and 12,000 people were injured. 220,000 homes were destroyed. The earthquake disrupted power, water supplies and communications across Chile. The cost of the earthquake is estimated to be $30 billion United States dollars. The surface of our planet may look like a solid shell, but according to the theory of plate tectonics, Earth's outermost layer, or lithosphere, is broken into large rocky plates. The plates move relative to each other at different rates, from 2 to 15 centimeters per year. The movement of the plates creates three types of tectonic boundaries: convergent, where plates move into one another; divergent, where plates move apart; and transform, where plates move sideways in relation to each other. Most earthquakes occur at fault zones, where tectonic plates collide or slide against each other. As mentioned earlier, many buildings were damaged by the earthquake, some even completely collapsed or fell. However, there were also those buildings that survived and were even completely preserved after minor restorations. But why did some buildings survive the earthquake with the horizontal acceleration of 0.56 g and some didn't? It depends on the materials they are built from and the degree of fortification. As buildings are made of concrete, which is strong but not flexible enough, these forces can stretch the concrete and cause it to crack. Engineers can fix this by adding a flexible steel frame made of what is called rebar. Casting rebar into the concrete increases the overall strength of the concrete and improves its ability to withstand loads. This is because rebar has elastic properties and can help the building return to its original shape. Buildings can also be equipped with base isolation systems to separate the building from its foundation using springs or runners. Various additional structures can also be integrated to maintain the strength of the building: shear wall, moment-resisting frame, or braced frame. At one of the seminars at university, we conducted a reliability analysis of the braced frame structure. Unfortunately, our building collapsed after the earthquake simulation because there was not enough time to complete the building, but nevertheless this structure was much stronger than simple use of columns. Another threat is landslides caused by earthquakes. In total, 1226 landslides were mapped over a total area of circa 120,000 km2. They destroyed up to 1,500 kilometers of roads, cutting off remote communities for days. In fact, it is possible to analyze the seismic stability of a slope of the Earth, knowing the composition of the Earth. Also, in one of the seminars, we conducted an experiment in which we created a small slope of sand and gave it several impulses, approximately similar to the impulses of the earthquake in Chile. The results showed that if we connect the points on the graph of acceleration against the angle of the slope, we can find a correlation between them. So the stronger the horizontal acceleration of an earthquake, the smaller the angle, and that means the landslide is stronger. Thus, the task of a civil engineer is not only to construct a building, but also to ensure its safety, taking into account the characteristics of the area.